Hello everyone, welcome to lecture 27, Inverse of Trigonometry Functions. So in this lecture, we're going to look at some properties and graphs of inverse of sine function, inverse cosine function, and inverse tangent functions. Also, we're going to find the exact value of inverse sine, inverse cosine, and inverse tangents of some angles. So now first, before we go to the definition of inverse sine function, inverse cosine functions, and inverse tangent function, I want to show the graph of sine of x, cosine of x, and tangent of x to explain to you what part of sine function, what part of cosine function, and what part of tangent functions are allowed to have inverse functions. So when you look at the graph of sine function, again, sine function is an odd function because the graph of the function is symmetrical with respect to the origins. In the lecture, when you talk about the properties in the graph of sine function, you know that sine function, the domain of the function is all real numbers from negative infinity to positive infinity. And the range is from -1 to 1, right? Because the amplitude is equal to 1. So when you look at the graph, you recognize that this is not a one-to-one function. To be able to find an inverse function, the original function has to be a one-to-one function. So obviously, sine of x is not a one-to-one function because it does not pass the horizontal line test. So how could you possibly find an inverse function of sine? But when you look at the function, if you just take the part from -pi/2 to +pi/2, so let me change the domain a little bit. So pi/2 to pi/2. So you can see in this case, the function is actually now a one-to-one function. So for the sine function, if you restrict the domain between -pi/2 to pi/2, you have a one-to-one function, okay? And when you have a one-to-one function, you could be able to find the inverse functions, okay? Now, similarly, when you go to cosine function, let me change this. So again, for cosine function is an even function because the graph is symmetrical with respect to the y-axis. Cosine, the domain of cosine function is from negative infinity to positive infinity. The range is between -1 and 1 because of the amplitude equal to 1. But when you look at the graph is not a one-to-one function graph, right? Because it does not pass the horizontal line test. However, if you just restrict the domain of the function to certain interval, you can actually have the one-to-one function. So in the case of cosine function, we restrict the domain from 0 to pi only, so just this part of the curve. Okay. I mean, you can do the same for the domain between -pi to 0, but you don't want to deal with negative number, right? So it makes a lot more sense when you just deal with something positive that is from 0 to pi. Okay. Now, let me go back to sine. You can take into considerations the domain between -pi/2 to pi/2, or you can take into account the domain between pi/2 to 3pi/2. But by conventions, the restriction is applied on the interval between -pi/2 to pi/2. So that is easier to see the connection between sine function and tangent function later. So now let me turn on the tangent function graph. Right? So in tangent function, the function can be written as sine over cosine, and the domain is everything except cosine of theta is different from 0. So that is, again, you look for the angle theta to exclude, right? Those are the odd number of pi/2. You get -3pi/2, you exclude that value. -pi/2, you exclude that value. Pi/2, you exclude that value. 3pi/2, you exclude that value. So on and so forth. So this is the graph of tangent functions. Okay, so for tangent function, again, this is not a one-to-one function at all by the look of that. But if you restrict yourself on the interval from negative pi over 2 to pi over 2, then you have a one-to-one function. Therefore, you can find the inverse of the function. Now compare between sine and tangent functions. You can see that if we choose the interval between negative pi over 2 and pi over 2, you can find the inverse of sine, you can find the inverse of tangent. But the difference between the two functions is that for sine function, you including negative pi over 2 and positive pi over 2, so you're including the endpoints. However, for tangent of x, the restriction is also avoiding the endpoints because of the domain of tangent functions. So you don't want negative pi over 2 in your domain. You don't want pi over 2 in your domain. So that's the difference between sine and tangent functions. Okay. As I briefly mentioned, you can consider the interval between negative pi over 2 to pi over 2, but you can certainly consider the interval between pi over 2 and 3 pi over 2, or 3 pi over 2 and 5 pi over 2, so on and so forth. But by convention, we just restrict ourselves on the interval between negative pi over 2 to pi over 2. So to conclude what I just mentioned, that you can find the inverse for sine function, cosine function, and tangent function if you restrict the interval or you restrict the domain of the function on certain interval. Okay. Now, with that in mind, I'm going to write out definitions for inverse sine function, inverse cosine function, and inverse tangent function. So for inverse sine functions, you have the new notations for the function. So you have y equal to sine of negative 1x. So this indicates this is the inverse sine function, and the negative to the negative 1 is not the power, but the indications of an inverse function. Okay. There's another notations to indicate the inverse functions in trigonometry that is called the arc sine function or arc cosine function or arc tangent functions that we're going to see later. So this can also be written as arc sine of x. Okay. So the inverse functions of sine is arc sine of x if and only if sine of y equal to x. Okay, so that is from this equations, you take sine on both sides of the equations, sine and sine inverse cancel out, and you're left with x on the right hand side. You apply sine on both sides of the equations, so that's why you get sine of y on the left hand side. Bear with me here. So this is the sine functions, right here, the one with the arrows. Right? Remember the explanations I had earlier, that sine function, even though it's not a one-to-one function, but if you restrict the function on the domain between negative pi over 2 to pi over 2, then you can find an inverse function. So in this case, let me use color red here, so you follow this function. Okay, so this is y equal to sine of x, and the domain of sine is going to be from negative pi over 2 to pi over 2, and the range, therefore, is going to be, again, between negative 1 and 1. Okay, because of the amplitude is 1, so that's why the range is equal to, the range is between negative 1 and 1. So let me change the color here to green. Okay. So the original function is sine function. The domain is between negative pi over 2 and pi over 2. The range between negative 1 and 1. So when you go to the inverse functions, the range becomes the domain and domain becomes the range. So the domain of the inverse of sine is going to be equal to negative 1 to 1. Now let me change the color here. And the range is from negative pi over 2 to pi over 2. Okay, so I hope that makes sense. I hope you know at this point where's the domain coming from, where's the range coming from, and why the range is between negative pi over 2 and pi over 2. Now, how could you locate this on the unit circle? So you start with negative pi over 2. So this is where you have negative pi over 2, including the endpoints. And you go to the right half of the unit circle. Right. So that is the part of the inverse function or inverse sine function. Okay. Now, moving on to inverse cosine functions, we're going to have a very similar definition, but different notations here. So you have y equal to cosine inverse of x or equal to r cosine of x if and only if cosine of y equal to x. Again, how can we get this equation? So you apply cosine on both sides of this equation. Cosine with cosine inverse cancel out. It's not mathematically correct, but it's convenient for us to say that to understand the problem. So again, cosine with cosine inverse cancel out, and you left with just x. Again, you apply cosine on both sides of the equation, so that's when you get cosine of y on the left-hand side. Now, let's take a look at the graph of cosine function. So this is the graph of cosine functions. Again, technically, cosine function is not a one-to-one function, okay? But we restrict the domain of cosine function between 0 and pi only. So this is the one in red, it's cosine of x, and the domain is between 0 and pi. Okay. If you restrict the domain between 0 and pi, then you have a one-to-one function, so therefore you can find the corresponding inverse function. Okay. And the range of the cosine function is also from -1 to 1 because the amplitude is equal to 1. Okay. And when you go to finding the inverse cosine function, the domain becomes the range becomes the domain. So the domain of the inverse cosine function is from -1 to 1, and the range of the inverse cosine function is from 0 to pi. Okay. Now, how could you locate this on the unit circle? So the range is from 0 to pi, including the endpoints. So you choose the upper half of the unit circle. Okay. Um, Now moving on to inverse tangent functions. So the inverse tangent functions in this graph, you can see, I'm going to choose red again here. So that is the tangent function y equal to tangent of x. And for the domain of tangent functions, you have to restrict the domain between -pi/2 to +pi/2 and do not include the endpoints because remember all vertical asymptotes at the odd number of pi/2. Okay. And the range for tangent function and cotangent function that we learned in the last lecture, tangent and cotangent function has a range that's go from -infinity to +infinity. So there's no restriction for the range. Now, when you go to inverse tangent functions, you get that y equal to tangent -1x indicates that this is the inverse tangent function, or it can be written as arc tangent of x if and only if tangent of y equal to x. Again, similar to the last two cases, you're going to take tangent on both sides of this equation. Tangent and tan inverse cancel out, and you're left with x on the right-hand side. Again, you apply tangent on both sides of the equations. That's why you get tangent of y on the left-hand side. For the tangent function, you get the domain restricted between negative pi over 2 and pi over 2 and do not include the endpoints. And you get the range to be from negative infinity to positive infinity. Then the domain of the inverse tangent function becomes negative infinity to positive infinity. And the range of the inverse function is from negative pi over 2 to pi over 2. Now we can locate the range on the unit circle as follows. So from negative pi over 2 to pi over 2. So very similar to the case of inverse psi functions here. You choose the right half of the unit circle, but you do not include the endpoints. So in this case, I use an open circle at negative pi over 2 and positive pi over 2. And this is the right half of the unit circle. So we just wrote down the definitions of inverse psi function, inverse cosine function, and inverse tangent functions. Hopefully, you could be able to understand where's the domain of the inverse function coming from, when the range of the inverse function coming from. Okay. And again, the original functions and the corresponding inverse function, the graphs of them are symmetrical with respect to the line y equal to x. So this is the line y equal to x. So this is the graph of psi inverse of x, or arc psi of x. Okay. Again, the original function and the inverse function are symmetrical with respect to the line y equal to x. And here is the graph of the inverse of cosine. So I write y equal to cosine inverse x, or this is arc cosine of x. Now, similarly, for the case of y equal to tangent of x, the corresponding inverse functions, the graph will be symmetrical with respect to the line y equal to x, and this is the line. Okay, so this is y equal to tangent inverse of x, or this is arc tangent of x. Okay. Now those are the definitions for inverse sine, inverse cosine, inverse tangent function. You see a little bit of the properties of the inverse function, including the domain and the range, and also the graph of the inverse functions. So now let me move on to something else. So in the next part, we're going to find the exact value of some inverse psi functions. So for instance, if we are given certain angles, so in this case is negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. So these angles are special angles. And again, why are we have this number? Because of the inverse psi function would restrict the domain between negative pi over 2 and pi over 2. Okay, so for psi of theta, psi of this angle, can you write down the values? So we know some of this already. Like for instance, psi of 0 is 0, psi of pi over 6 is equal to 1/2, psi of pi over 4 is equal to 2 over 2, things like that. So let me fill out the information for psi of theta. So psi of 0 is equal to 0, psi of pi over 6 is 1/2. Psi of pi over 4 is √2 over 2. Psi of pi over 3 is √3 over 2. Psi of pi over 2 is 1. Okay. So now what about psi of negative pi over 2, negative pi over 3, negative pi over 4, and negative pi over 6? So you remember when we learned about the property of psi function is an odd function, so therefore psi of negative theta is equal to negative of psi of theta. So psi of negative pi over 6 right? So for instance, you have psi of negative pi over 6 is going to be equal to negative of psi of positive pi over 6. And you know the value of psi of pi over 6, so just put in a negative value and you get the answer for psi of negative pi over 6. So that is the psi of negative pi over 6 is negative 1/2. Now, similarly, negative psi of negative pi over 4, so that should give you negative root 2 over 2. So again, the idea is that you have a psi of negative pi over 4 should be equal to negative of psi of pi over 4 due to the fact that psi function is a non function. Right? So psi of pi over 4 is equal to root 2 over 2. So therefore, psi of negative pi over 4 is equal to negative root 2 over 2. And we're going to fill out psi of negative pi over 3 should be negative of root 3 over 2. Negative root 3 over 2. And psi of negative pi over 2 is equal to negative 1. So, okay. So let's say you are given some special angle here and asked to find psi of those angle. And now you know the value of those angle. Okay. What if in the case that I give you this value in green and in red, and I ask you to look for the value of theta such that psi of theta is equal to these values. So that's the question for us to find the exact value of the inverse functions. Okay. So in example 1, you want to find the exact value of arc psi of 1/2. So how could you find that? So there's certain procedure that I'm going to follow not only for inverse sine function, but also for inverse cosine and inverse tangent function. So for arc psi of 1/2, you say that you're looking for an angle theta, right? If and only if psi of theta is equal to 1/2. Right, so this is the inverse of psi of 1/2. Will give you the angle. Or in other words, you're looking for the angle such that psi of angle, right, theta, is equal to 1/2. Now you go to the table, this table right here, and you say that psi of theta equal to 1/2, the theta must be pi over 6. Okay, so I hope that helped. Okay, and remember for the angle, for the domain of inverse of the function is restricted, for the inverse of the function is restricted between negative pi over 2 and pi over 2. So that's why the angle that we only have is between negative pi over 2 to pi over 2. Okay. So therefore, um, you say that where theta is between pi over 2, negative pi over 2 to pi over 2, then you conclude that theta is equal to pi over 6, or technically what you're trying to find is r psi of 1/2 is equal to pi over 6. Now moving on to part B. Problem B say that can you find r psi of root 3 over 2? So you're looking for an angle theta, right? If and only if or such that psi of the theta is equal to root 3 over 2. Okay. So how did I get this equation? Again, what you do is you take psi on both sides of this equations, and you get that psi with the inverse side cancel out, and you're left with root 3 over 2. And on the right-hand side, you have psi of theta. Okay, so you look for theta such that psi of theta is equal to root 3 over 2. So root 3 over 2 is right here. Psi of theta equal to root 3 over 2. The corresponding angle, or the inverse, when you go back, is pi over 3. Again, I want to classify that the theta in this case has to be between negative pi over 2 and pi over 2 because we are dealing with inverse functions of sine. Then theta that you're looking for is pi over 3 or arc sine of root 3 over 2 is equal to pi over 3. Okay. Now in problem C, I'm going to switch the notations a little bit. Instead of arc sine, now I have sine inverse of negative 1. Again, you're looking for the angle theta if and only if, or such that sine of theta is equal to negative 1. Again, how would you get this equation? So you take sine on both sides, or you apply sine on both sides of this equation. So this one is theta sine. So sine with inverse sine cancel out and you're left with negative 1. Because you apply sine on both sides of this equation, you have sine of theta equal to negative 1. Again, I want to emphasize that theta is between negative pi over 2 to pi over 2. And with sine of theta equal to negative 1, you're looking for the corresponding angle. So in this case, it's negative pi over 2. And then theta that you're looking for is negative pi over 2, or sine of negative or inverse sine of negative 1 is equal to negative pi over 2. Now in the last problem, inverse sine of square root of 2 over 2 is equal to theta. I'm looking for the angle theta such that if and only if sine of theta is equal to root 2 over 2. Again, one more time here, you take or you apply sine on both sides of this equation. And you have sine and the inverse cancel out, and you're left with root 2 over 2. And on one side of the equations, and sine of theta on the other side of the equations. So sine of the angle that you're looking for is equal to root 2 over 2 right here. So the corresponding angle must be pi over 4. Again, I want to emphasize that the theta has to be between negative pi over 2 to pi over 2 because we are working with the inverse of sine functions. And then theta is equal to pi over 4, or inverse sine of root 2 over 2 is equal to pi over 4. Now let's move on to inverse cosine functions. So what we do first is that we're going to fill out the table of the special angle and the corresponding cosine of function. So here on the first row is the angle 0 to pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Why this number? So these angles are special angles, and for the inverse cosine function, we just restrict the domain between 0 and pi. Right? The cosine functions that we need, the domain of the cosine function that we need to restrict ourselves is between 0 and pi. Okay, so cosine of 0 is equal to 1. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. And cosine of pi over 2 is 0. Okay. So for the upper half of the unit circle, so the angle from 0 to pi over 2 will give you cosine of positive value of cosine. But between pi over 2 pi over 3 to pi, the cosine values are going to be similar, but in the negative sign. So 0 in the middle, 0 in the middle, and then you reflect everything to the other side, but stick the negative number in there. So the so cosine of 2 pi over 3 will give you negative 1/2. Cosine of 3 pi over 4 is negative root 2 over 2. Cosine of 5 pi over 6 is negative root 3 over 2. And cosine of pi is equal to negative 1. Right. So look at the unit circle again. You have that. So the upper half of the unit circle, from 0 to pi, the x value or the cosine value on the first quadrant is positive, and the cosine value on the second quadrant is negative. So that's the reason that we have one side of this table is positive values, and on the other side is the negative value. Okay. Now for cosine, for inverse function, we're looking for our cosine of 0. So again, this is equal to theta. You're looking for the angle such that, or if and only if, cosine of theta is equal to 0. So you're looking for the theta such that cosine of theta is equal to 0. Now for the table, so cosine of theta is equal to 0. The corresponding angle must be pi over 2. And again, I want to emphasize the domain. That is where theta is between 0 and pi and including the endpoints. Then theta is equal to pi over 2, or arc cosine of 0 is equal to pi over 2. So for part B, you're looking for arc cosine of positive 1/2. So that is, you're looking for the angle theta such that, or if and only if, cosine of theta is equal to positive 1/2. Okay. Remember that value of theta is between 0 and pi only in this case. Then the corresponding value of theta, so we have 1/2 here, the corresponding value of theta is pi over 3. So theta is equal to pi over 3, or cosine of pi of 1/2 is equal to pi over 3. Well, cosine inverse of negative root 2 over 2, again, this is equal to theta. You're looking for the value of theta such that, or if and only if, cosine of theta is equal to negative root 2 over 2. Again, how can you get these equations? You take cosine on both sides of the equations, and you get cosine in the inverse cancel out. So you get negative root 2 over 2 on one side of the equations, and cosine of theta on the other side. And again, the value of theta is between 0 and pi only in this case. So then we look at the table, you can see that theta is equal to 3 pi over 4, or the inverse of cosine of negative root 2 over 2 is equal to 3 pi over 4. The last problem here, we are looking for the inverse cosine of root 3 over 2. So we're looking for the angle theta such that, or if and only if, cosine of theta is equal to root 3 over 2. Okay, where theta is between 0 and pi. Then if you go to the table, you will see that positive root 3 over 2 here, cosine of theta equal to root 3 over 2. Corresponding angle must be pi over 6. Then you have theta equal to pi over 6, or inverse cosine of root 3 over 2 is equal to pi over 6. Now we're going to move on to our tangents or the inverse of tangent functions. And if you recognize this number in the table is very similar to the case of sine function, the inverse sine function. It's just that we ignore the endpoints negative pi over 2 and pi over 2. Okay. So here in the first row, we have the angle theta, but without the endpoint negative pi over 2 and pi over 2. So tangent of 0 is 0. So tangent of pi over 6 is root 3 over 3. Tangent of pi over 4 is 1. And tangent of pi over 3 is root 3. And remember, tangent function is an odd function, so tangent of negative theta is equal to negative of tangent of theta. Therefore, when you're looking for the value of tangent of negative pi over 6 is actually equal to negative of tangent of pi over 6. Right. So you get this is negative root 3 over 3. Okay. So technically, 0 is the middle point, and you just mirror all of this value to the other side, but with a negative sign to include in the answer. Okay, so tangent of negative pi over 4 is negative 1. Tangent of negative pi over 3 is negative root 3. Okay. Now, that's the forward directions. Given the angle theta, can you find the corresponding tangent value? Now, in the case of giving you the tangent of theta, can you find the corresponding angle? So in example 3, you have our tangent of 1. So you're looking for the angle theta such that or if and only if tangent of theta is equal to positive 1. So the only value that we have in this case here, right? The corresponding angle is pi 4. Remember, the value of theta is restricted between negative pi over 2 to pi over 2, but do not include the endpoints. Then theta is equal to pi over 4, or our tangent of 1 is equal to pi over 4. Now for part B, you're looking for our tangent of root 3. So this should be equal to an angle that you're looking for. So we're looking for the angle theta such that, or if and only if, tangent of theta is equal to root 3. Again, how can we get this equation? So you take tangent or apply tangent on both sides of the equations. So tangent with our tangent cancel out, and you're left with square root of 3 on one side of the equations, and tangent of theta on the other side. I want to emphasize one more time that the angle that we're working with has to be in between negative pi over 2 to pi over 2. Then the angle that we're looking for, so tangent of theta is equal to root 3. So the corresponding angle must be pi over 3. So then the angle theta is pi over 3, or our tangent of root 3 is equal to pi over 3. Now for tangents, inverse tangents of negative root 3, so this is the angle we're looking for, the angle theta, if and only if we have tangent of theta equal to negative root 3. And again, you may wonder where's the equation coming from. That is, you take tangent on both sides of the equations, tangent with the inverse tangent cancel out, and you get negative root 3 on one side of the equations, and tangent of theta on the other side, where theta is restricted between negative pi over 2 and pi over 2, but do not include the endpoints. Then you have that theta. Okay, so tangent of theta is equal to negative root 3. right here. So the corresponding angle should be negative pi over 3. Or tangent inverse tangent of negative root 3 should be negative pi over 3. And for the last equations, you have this inverse tangent of root 3 over 3 equal to theta. That is, you're looking for the angle theta such that, or if and only if, tangent of theta is equal to root 3 over 3, where the angle theta is restricted between negative pi over 2 to pi over 2. Then you have the angle theta that you're looking for is, excuse me, over here. So this should be root 3 over 3. So positive root 3 over 3, so the angle is pi over 6. Or tangent inverse of root 3 over 3 is equal to pi over 6. And so that's it for me for this lecture. Please let me know if you have any questions. Thank you.